Now we want to begin doing kinematics. That is, if we want to describe the motion of this ladybug, her position and velocity under the action of her acceleration, and we want a mathematical description for these quantities, what we'll be doing is kinematics. For example, we might study the circular motion of the ladybug. Here she is going around in a circle. She's clearly got velocity, acceleration. She's changing her position. Mathematical description of this motion would be 2D kinematics. Most fundamental quantity we're going to want to define as we begin our study of kinematics is displacement. So here it is. Displacement is the directed straight line distance between 2 points. So if we draw an arrow between point A and point B like that, that is the displacement. And the magnitude of the displacement will be the size of the arrow, say 2 meters. And the direction of the displacement, we'll have to give that. So in this case, maybe it would be 20 degrees above the x-axis. For example, let's say we want to measure a ladybug making a displacement right here. So there, we just watched a ladybug make a displacement between 2 points. So let's go ahead and figure out what's the magnitude of that displacement. Notice that the magnitude of the displacement the ladybug makes in going from point A to point B, we measure directly with this tape measure here, is 4 centimeters. That is, it's 5 centimeters minus 1 centimeter, the delta. So the displacement is final minus initial position, and you notice it doesn't matter there. The displacement doesn't depend on where we put the tape measure, right? I can put my tape measure right there and see that the displacement is 4 centimeters. And in fact, this displacement is a 1D quantity. We could look at it like this. Define the x-axis in centimeters to be along the displacement. So here what we did is we rotated the x-axis to be horizontal, right? We saw the displacement was at an angle. Maybe it was at an angle of 20 degrees above the x-axis. Or I mean above the horizontal, not above the x-axis. So since the motion was in 1D, because it was all along a line, we emphasize that now by just rotating the x-axis to be horizontal. That way it corresponds to how we view the x-axis more often as being directed along the horizontal. Again, notice it doesn't matter. It doesn't matter how we measure the displacement with our centimeter stick here. So I can measure the displacement as 6 minus 2 is 4. I can measure it as 5 minus 1 is 4. Or just measure it as 4. 0 minus 4 is 4. So the magnitude of the displacement doesn't depend on how we orient our ruler or place our ruler. So now we can see how to define displacement. Displacement, which we'll call delta x in 1D, then is going to be x minus x0, where x is the final position and x0 is the initial position. So in this case, using our tape measure, what do we have? X minus x0 is 4 minus 0 equals 4 centimeters. Also, we saw we had the same delta x. Say if we moved our centimeter stick, I'm not going to cut it and try to move it again here. But you saw when we moved it over to here, we effectively placed the start of the motion no longer at 0, but at 2. And in that case, what did we have? We had delta x would just still be x final minus initial. In that case was 6 minus 2, still equal 4. centimeters. So it's the same either way. So that's it. That's displacement in 1D. It's quite simply what you measure with your tape measure. Start from point A, go to point B, and you measure that with your tape measure. It's a directed straight line distance that you measure, and it's right there. So we have the displacement as the directed straight line distance between 2 points, say between points A and B. And if the action of the displacement happens all along a line, like the line between A and B, then we can view that line to be the x-axis, and if we like, we can even turn it horizontally like that. So the x-axis corresponds to how we like to see it horizontally. Even if the action, as long as it's on a line, we can look at it like this. It's virtually the same. The direction is kind of independent. Okay, so in just for something explicit here, we could just say this is the point 1 and this is the point 4 meters along the x-axis, and then we can see, according to our definition for displacement, delta x, final minus initial, is in this case, we start at A, go to B, that's 4 minus 1 equals 3 meters. Okay, so that's great. But now let's say, what if we had gone from B to A? So let's say we go from A to B, and then we go from B, and then back over to A. Okay, so that was the displacement from A to B. What would the displacement from B to A be? Okay, so again, it's final minus initial, and that is 1 minus 4 is minus 3 meters. So here we see that the direction of the displacement is given by the sign of the displacement in the case of 1D. When the displacement is positive, say 3 meters to the right, then the displacement is greater than 0. And when the displacement's negative, minus 3 meters to the left, that's less than 0. So if the displacement's positive, that means it's to the right, or if the displacement's negative, that means it's to the left every time. And what would the displacement be if we had gone from A to A? Right? We go from A to B, then A to A again. Well, in that case, you could see that's just 0, right? You started right back where you ended. You know, this would just be x minus x, if you like, or something like that. Or x minus x0 would just be, what, 1 minus 1 equals 0. So you could have a net displacement of 0. You can go back to where you started. Okay, so we've defined displacement. And as soon as we do that, another kind of concept could come up, this concept of distance. How does that come up? Okay, so a displacement is the directed straight line distance between 2 points, say point A and point B, point 1 and point 2, or from the log cabin to the lake. So here's the displacement, so the directed straight line distance from the log cabin to the lake. Here we can see it's, if you take the trip straight along the line here, straight line displacement, that's the shortest route you can go along a straight line, 5 kilometers from the log cabin to the lake. We can see, oh, these other paths we can go. We didn't have to go from the log cabin to the lake along the line of this displacement here from the log cabin to the lake, right? We could have taken path 2, say the upper trail, and maybe that's 9 kilometers. Or we could have gone path 1, the lower S loop. I don't know, let's say that's 8 kilometers. And I'm writing down this 9 kilometers, 8 kilometers. What am I writing down? The displacement? No, the displacement's 5 kilometers, and it's directed 40 degrees north of east. So that's the displacement. What are these other things? Well, they're the distance that you actually go to make that displacement. And the only time the distance that you actually go to make the displacement is the same as the displacement is when you go along a straight line from point A to point B, or from the log cabin to the lake. So that's why there's a difference, right? That's why we can't just think, okay, everything's just displacement, right? That's actually displacement in a way is more fundamental than distance, because if you're sitting there with a tape measure, let's say like a hard ruler, it's going to be pretty natural for you to measure along a straight line in some direction. So most measurements you make are literally some kind of displacement. Now you could have some floppy tape measure where you measure the distance, right? That's actually the tread wear, your odometer reading. You see what it is right there, right? It's self-evident once you look at it. I think you're getting what it is right now. And there's one more time where the difference between distance and displacement is quite stark, almost embarrassing, right? If you only had displacement. Well, I'll show you what I mean. Let's say you make this trip. Go around in a circle. So you start and end at the same points here. So x and x0 are both at this point right here. You went around in a circle. What was your displacement? Well, it's 0 because x minus x0, they're both the same point. So overall you went nowhere. But if you were driving a car, right, you got an odometer reading for that. Definitely, right? That there's wear and tear on the car. What was it? So the distance that you would have gone then would have been 2 pi times the radius, your distance around the circle. So that's the difference between distance versus displacement. We are done with this topic. Good physics to you.